All right, so question number 7, a continuous curve as equation. The curve has a stationary point at P point. Show that the x coordinate of P is the solution of this one. So, okay. So obviously the curve has stationary points. So everyone knows when the curve has stationary points, so dy over dx will be equal to 0. So let's take dy over dx. So there are two operators, sine, trigonometric and exponential operators, and both are rejected actually. So you have to apply product rule because the box of sine will be 3x and the box of e will be minus xk. No one is completely inside the box of another operator. So that's why it will reject. So when the both are reject, so obviously you have product rule and quotient rule. So let's apply product rule. How to apply product rule? U into v, that u into v, derivative of v. So let's take the derivative of v separately. The derivative of sine of 3x will be cos of 3x. Further, the derivative of box will be, the derivative of 3x will be 3. So 3 cos 3x. Perfect. Everyone knows how to apply product rule. So u as it is, take the derivative of v, plus v as it is, take the derivative of u. And u is actually beta e raised to power minus x square. How to take the derivative of u? First you have to write as it is, then take the square of this exponential power. Sorry, take the derivative of exponential power. The derivative of minus x square will be minus 2x. Perfect. So that will be e raised to power minus x square into minus 2x actually. Minus 2x actually. Perfect. So I have to put dy over dx equal to 0. Let's simplify further. Make sure your calculation should be strong. Be careful after that. Put dy over dx equal to 0. So what you can take common from the right side? I can say, okay, I want to prove x equal to 1 over 3. Arc tan means beta tan inverse of 3 by 2x. और balance नहीं है, okay, perfect. So let's take common anything if it is possible to the right side. Yes, I can take common e raised to power. Then the remaining term will be 3 cos 3x minus 2x sine 3x. This one equal to 0 or maybe this one equal to 0. And obviously exponential function cannot be equal to 0. Remember. So I want to get tan. So tan is actually sine over cos. So equal to 2x sine 3x. So what it will become? Sine over cos will become tan 3x. And 3x equal to tan inverse of. But arc tan means tan inverse. 2x, so x will become 1 over 3 tan inverse 3 over 2x. I think that is what we want to show. Simply be careful about how to take the derivative of function. How to apply product rule. U as it is, then take the derivative of v, plus v as it is, then take the derivative of u. And as you know that we have a stationary point at P point, so you have to put derivative equal to 0 and then simplify, then you get the answer. We want to prove 1 over 3 tan inverse 3 over 2x. Perfect. Perfect. Okay, find the value of x2. Yes, this part is very easy. How you can get x2? X1 value is available already. So put n equal to 1, then you can get beta 1 plus 1, 2. Tan inverse 3 over 2x1 actually. Just substitute the value 2 into x1. X1 is 0.4. And use calculator and write the answer in how many decimal places? 4 decimal places. Three, 6, 7 actually. That is x2 value. Let's figure out the x4 value. It's not necessary to show your working beta. Just write the answer of x4 directly. How you can get x4 actually? First you need to find x3. So put n equal to 2. Then you will get x3 1 over 3 tan inverse 3 over 2 times x2. So what is the value of x2? 2 times 0.4367. So if you want to find x4, obviously first you need to find x3 beta. Even you can't, no need to show working, just write the final answer. I just want to show how it can works actually. So 0.4292 actually. So now you can get the value of x4 easily. So sir, how you can get x4? I have to substitute n equal to 3, which will become 1 over 3 tan inverse 3 over 2 times x3, and x3 value is 0.4292. This is almost approximate estimate value. Perfect हो गया 0.4292. Wait, divided by 3. 0.4307. So using a suitable interval, I want to show that the x coordinate of P is this. Okay. So using a suitable interval, let's take two values of x between 0. So let's take the slightly smaller value 0.430. Everyone knows 0. Let's take 0.429 and let's take 0.432. All right, so now we have to use this function. Do not try to use our original function. Be careful about that. Everyone knows. What I have to do? I have to make one side 0 and then put 0 with y. Please, now you have to substitute these values to this function and this function. So put these values of x into this function. If the sign will change, so obviously it has a root. Sign should be changed, but chalo. So x value is 0.429 minus 1 by 3, 10 inverse 3 over 2 times 0.429. Put in your calculator directly and check the sign. This is negative 1.74. So this is negative sign, and let's check the sign of this function. So this is positive. The sign should be changed. What do you have to write at the end? Yes, the sign has changed. So it means root will exist. So yes, x is the what do you want to ask? X is the coordinate of P point, which is 0.430. Simple. Simple, straightforward. I don't think there is an issue. Please be careful. Always at the end, examiner can ask about this type of question using a suitable interval. So you have to take slightly smaller value of 0.430 and slightly bigger value of 0.430 and put into the function. But after that, first you have to make 0 to the one side and replace 0 with y. Then be careful, you have to put into the function. After that, beta, if the sign will change, yes, will always change in P3, and at the end you can say yes, the root will exist. That is a part of answer. Perfect.